Good afternoon. Here's our practice problem for the day, and we're preparing for our final evaluation related to the integration of integer operations and geometry or movement on the Cartesian coordinate plane or coordinate system. So first off, in the bottom left-hand corner we have a player. Now the player is represented by the variable p, and the player's coordinate is -2, 8. -2 representing the x-coordinate and 8 representing the y-coordinate. So that means the player should be -2 and then 8. So it could be moved over a little bit to the right, but regardless, it's in approximately the right spot. Now the target is at 12. So if we start at the origin and count 12 spaces over to the right, and then 5 spaces down, we end up in the midpoint of the target. So we've got the coordinates of the target and the player, and the question is, if the target translates -8, 0, then what translation would the player also have to make in order to catch the target or make contact at the same point on the Cartesian coordinate system? Well, this translation says -8, 0. The first number represents movement in the x-axis. The second number represents movement in the y-axis. Therefore, the target is only moving in the x-axis because the y-axis number value is 0, meaning there's no movement up or down. So it's only going to move left or right. The question is, does the target move to the left or to the right when we add -8? So here's a visual representation of the target itself. Now the target is labeled as t, and we're going to be using Explore Learning Gizmo translations. Now this gizmo doesn't allow us to change the label, but I want you to pretend that A on the grid actually represents t for the target. So what I've done is I've taken the coordinates 12 and -5, where the target is currently located, and I've put them into my pre-image matrix. And you'll notice that once the numbers are typed in, the point pops up on the grid. So if we start at the origin, count 12 over to the right, and then count 1, 2, 3, 4, 5 down because it's -5, movement on the y-axis, we find the original point or placement of the target. Now the target is going to be translated -8, 0. So we can use our translation markers to put in the translation -8 for the x-axis and then 0 for the y-axis. That means t prime, or the final image of target, should be 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, and that's marked by j. So j is actually representing the location of t prime. So you'd have to represent that or describe it if you're going to be using this gizmo to help you explain yourself. So once we know where the target ends up, we need to identify the current location of the player and then where the player would have to go in order to access the same point of 4 and -5. The player's original position is at -2 and 8. So it's marked off here by A. And you can see that right there. That means that in order to plot the player's position, we start at the origin. We walk 2 spaces to the left along the x-axis to represent -2, and then we walk 8 spaces up to represent movement on the y-axis to find the original location of the player at -2 and 8. Now, do you remember where the location of the target is after it's translated? That's important to put onto your grid and then try and figure out how many spaces left or right and how many spaces up or down the player would have to move in order to access the target after it translates. Now we can use integers to represent, or we can use the integer chip gizmo to help represent the calculation for the movement of the target after while we add the translation. So the target starts at 12, and then we're going to be adding -8. So we can find out the x-coordinate position of the target by adding -8. So we've added -8, and then we can combine our positives and negatives to apply the zero principle to our calculation, and that will tell us where the target's image will be located on the x-axis. This says that the x-coordinate for the target would be 4 after the translation was applied. And the y location, or sorry, the y, because it starts at -5, and then we apply 0 to that, or add 0, it stays at -5. I'm just going to do another quick check and show you again. So we had 12. So this is for the x-axis in the target, and we're going to apply the x translation of -8. And then when we combine the 0 principal, we end up identifying the new x coordinate after the translation is applied, which should be 4. And it is. So that means 12 plus -8 equals 4. That would be the x point of the image, of the target image. And then the y would be -5 plus 0, which is -5. So straightforward. Now what we need to do is represent the location of the target, represent the location of the target image by applying the translation, represent the position of the player, and then represent the translation required to move the player to the target image position.